Hello everyone. Today we are going to study the topic moment of inertia of the sphere about diameter. So let's us understand the difference between the sphere and a circle. Sphere is a three-dimensional figure whereas circle is a two-dimensional figure. Example of circle can be considered as triangles, and in example of sphere you can consider football, cricket ball, etc. Here I have drawn a sphere with red color ink. Now let I be the moment of inertia of this solid sphere, which we are going to find out later. Now let x dash be the diameter of this sphere. Let capital R be the radius of this sphere. Now we have assumed that this solid sphere is made up of large number of circular discs. So I have drawn one circular disc here with green color, which has the radius small r, whereas small r is the radius of this small circular disc. Let OB is the distance between the center of sphere and circular disc. We have considered this distance as x. Now here we are going to find the value of this small r. Why we are going to find? Suppose if I have taken another circular disc here. So here the radius of this circular disc, which is shown by the orange color, will be different as compared to the radius of the circular disc with green color. That's why first of all we need to find the radius of circular disc. So we are going to derive the radius of circular disc. Now from figure you can see in triangle ABO. So to find the radius of circular disc, here I am writing in triangle ABO. Here you can see that angle B is 90 degree. So here we can easily use the Pythagoras theorem. So here I am writing using Pythagoras theorem. Using the Pythagoras theorem in triangle ABO. So in triangle ABO, distance AO is nothing but the capital R. OB is nothing but the small x, and distance AB is small r, which is the radius of that circular disc. Also we are considering that dx is the thickness of this circular disc, which is shown by green color. Okay. Now here I am going to use the Pythagoras theorem. So according to Pythagoras theorem, here I can write small r square plus x square is equals to capital R square, whereas capital R square is nothing but the hypotenuse square. So here I am writing, rearranging the, therefore r square minus x square is equals to small r square. Now taking square root, here I am writing taking square root on both sides. Taking square root on both the sides. So after taking the square root, we finally get small r is equals to under root capital R square minus x square, where small r is the radius of this circular disc, which we have considered. Dx is the thickness of this circular disc. Capital R is the radius of sphere, and small x is the distance between center of sphere and circular disc. So this was our step number 1, where we have find the radius of circular disc. In further steps, we are going to use this small r value. So now in step number 2, we are going to find the volume of this small circular disc. So in step 2, what I am going to do, I am going to find the volume of this circular disc, which I have shown with green color. So here I am writing volume of circular disc. So I am denoting this volume as V dash is equals to, and the formula is area into thickness. Now we know the formula, area of circle is nothing but the pi r square. So area I am writing pi r square, and thickness which we have considered is dx. So here writing thickness is dx. And now give this equation number 1. So here I am substitute the value of small r in above equation. So here I am writing from equation 1, substitute value of small r, in above equation. So after substituting the value, v dash v is equals to pi as it is. Now the value of r square. So we have find the value of r. After squaring, we get r square minus x square into dx. So give this equation number. So this was step number 2. Now in step number 3, we are going to find the mass of this circular disc. So in step number 3, I am writing mass of disc. Here we have considered the circular disc which I have shown with green color. So here I am writing mass of circular disc. Which I am denoting with small m, and its formula is volume into mass per unit volume of sphere. So don't get confused here. Here we have find v dash, which was the volume of this circular disc, and here mass per unit volume is the volume of the sphere. So here I am writing, therefore m is equals to, so what was the value of v dash? Here I am writing volume as v dash, so you won't get confused. So here volume was pi r square minus x square into dx. Now mass per unit volume. Let us assume the mass of this solid sphere as capital M. So here I am writing capital M is the mass of solid sphere, whereas small m is the mass of circular disc which we are going to find. And we know the volume of sphere, which is 4 by 3 pi r cube. So here I am writing one note. Capital M is the mass of sphere and volume of sphere is 4 by 3 pi r cube. Volume of sphere is 4 by 3 pi r cube. Here remember that r, capital R is the radius of sphere as we have considered, and small r is the radius of circular disc. So again from our equation, so therefore let's simplify this equation. M is equals to, now let's cancel out some terms. Here we can cancel out pi and pi, and after simplifying we can simply write this 3 which is in denominator will go in the numerator. 3m upon 4r cube as it is, and the remaining term r square minus x square into dx. I have simply just rearranged this term. So give this as equation number 3. So in step number 3 we have find the mass of circular disc which is small m. Now in step number 4 we are going to find the moment of inertia of this disc above x dash. What was x dash? X dash is nothing but the diameter of the sphere. So here I am writing in step number 4. Step number 4, we are going to find the moment of inertia of disk of the sphere about xx dash. So we are going to find the moment of inertia of this circular disk. So let us denote this moment of inertia by di. Okay. See, here we are considering the solid sphere, and in the beginning, as I told you, we have considered this solid sphere is made up of n number of this circular disk. So if here we can find the moment of inertia of this circular disk, which I have shown with green color, and after integrating that, we can find the moment of inertia of whole solid sphere. So moment of inertia here we can find. So here I am writing the formula. Moment of inertia is equals to half into mass into radius square. So this is the formula of moment of inertia, as you know. So here mass is small m, okay, and radius is small r. Here we are considering the mass of this circular disk and radius of this circular disk and mass of this circular disk, not the solid sphere. So therefore di is equals to 1 by 2. Now from equation 3 I can substitute the value of small m. So here I am writing 3m upon 4 r cube r square minus x square into dx. And what was the radius? Small r, which we have found out in equation number 1, under root r square minus x square. So here it is the radius square. So I can write into r square minus x square. In next term, we are going to simplify this again. So I can here multiply this term. So it will become 3m upon 8 r cube, and here r square minus x square into r square minus x square will become r square minus x square whole square and dx as it is. So this is the moment of inertia of circular disk. So give this equation number 4. Now as I told you, this solid sphere is made up of n number of this circular disk. So here we can integrate. So in step number 5 I am writing step 5, moment of inertia of sphere, moment of inertia, that is capital I, of sphere about x dash axis can be obtained by integrating this small di, which is the moment of inertia of circular disk, for all elementary disk, within the limit x is equals to capital R to x is equals to minus capital R. So here let us understand why I am written here x is equals to R to x is equals to minus R. So in this solid sphere, as you can see, here we can consider O as the origin. In graphical form, we all know that if I draw here a graph, okay, this was our origin. So upper part will be always the positive value, and in the lower part of this origin will always be a negative sides. Okay, so that's how we are considering this solid sphere. The upper portion of this from this origin we are treating it as positive, and lower portion will be treating as negative. But we all know that length cannot be a negative quantity. So we are going to adjust that term in further steps. So here I am writing, therefore I is equals to nothing but the integration of di with limits minus r to plus r. Therefore I is equals to minus r to plus r. Now here I am substituting the value of di which we have found in equation number 4. So here I am writing 3m upon 8r cube r square minus x square whole square into dx. Now see, length cannot be a negative quantity. So here I am doing some arrangements. What here I am doing is I is equals to, see, twice 0 to r 3m 8 r cube r square minus x square whole square into dx. So see what I have done here. If we consider O as the origin and upper part is positive quantity and below part is negative quantity. So what if I only consider this semicircle? Okay, you know the meaning of semicircle, only the upper part of this solid sphere. From the point O, which we are considering origin, we are considering only upper part. And if I multiply this semicircle with 2, if I multiply this semicircle with 2, we will finally get the full circle. So here same case also applies in case of solid sphere. So I am considering only upper portion of this solid sphere and I am going to multiply by 2. So ultimately we are going to get the full solid sphere. So that's what I have done here. I have taken 0, which means I have taken from this origin and I have considered only upper part. Upper part means positive r and I have multiplied by 2. So we are getting, in case of just a semicircle, we are getting the full circle, and same applies in case of solid sphere also. So that's why our equation becomes I is equals to twice and limit becomes 0 to r and di as it is. So I hope it clears all your doubt here. See one more time. If we consider O as the origin, in coordinate axis, upper part of the origin is positive value and below part is negative value. But if we consider the limits from minus r to plus r, so here it is violating the rule that length is negative quantity, but length cannot be a negative quantity. So avoid this confusion. We are considering just this upper portion from this origin. And what we are going to do? We are going to multiply it by 2. So we are getting the full solid sphere. So here I am writing. Now here I can simply cancel out this term one time and this 4 times. So I can write the remaining term. So therefore I is equals to limit 0 to r 3m upon 4r cube r square minus x square whole square into dx. Now here we know one identity. We know one identity. Here I am writing here. We are going to use an identity. So which identity? You can guess. A minus b whole square. See here, r square minus x square raised to power 2. So here I am using the identity a minus b whole square, which is a square plus b square minus twice a b. So give this equation number 5. So here I can write using the identity, using above identity in equation number 5. So our equation number 5 becomes I is equals to limits. See here 3m upon 4r cube is a constant term. So I can write here outside of integration 3m upon 4r cube. So I have written it outside the integration, where capital M is the mass of this solid sphere and capital R is the radius of this solid sphere, which is not changing. What is changing is the only the circular disc and its radius. So I have written it outside the integration sign, 0 to R. Now here I can expand this term using the above identity. So here a square plus b square minus twice a b bracket close into dx as it is. Now in the next step, I can integrate each and individual term separately. So here I am writing 3m upon 4r cube. Here I am writing square bracket. So I am integrating each and individual term separately. So 0 to r raised to power 4 dx plus integration limit 0 to capital R x raised to power 4 dx minus integration 0 to capital R 2r square x square into dx, and this bracket close. Therefore, I is equals to 3m upon 4r cube as it is. Now see here, as I have told you, capital R is the radius of solid sphere, which is not changing. So I can take it outside the integration, 0 to r into dx, plus I am writing this term 0 to r x raised to power 4 dx as it is, since we are going to integrate this term, minus also here I can take out 2r square outside the integration, r square outside the integration, 0 to r x square dx and square bracket close. Now here you can now integrate. Therefore I is equals to 3m upon 4 r cube, r raised to power 4 as it is, integration of dx is x limit 0 to r plus integration of x raised to power 4 is x raised to power 5 upon 5 limit r 0 minus 2r square as it is, and here integration of x square is x cube by 3 limit r and 0. So let me remove this bracket from here. We use another bracket. Here we can use curly bracket. Okay. Now further I can simplify this above equation. Therefore I is equals to 3m upon 4 r cube, r raised to power 4. Here see I am simplifying these terms again, 0 plus, now I can write this term as 1 by 5 x raised to power 5 limits r to 0 minus, here I can write this term as 2r square, and I can take 3 here below it. Since it is multiplication, I can do that, into x raised to power 3 r and 0 are the limits. So square bracket close. Now here we can put the limits, substitute the value. I is equals to 3m upon 4r cube square bracket r raised to power 4. Here I can write r minus 0. I put the limits 1 minus 5 r raised to power 5 minus 0 minus 2 r square by 3. Here also r raised to power 3 minus 0, and this bracket got closed. So therefore I is equals to 3m upon 4 r cube. So here I can write r raised to power 4 and this will be r. So it will become r raised to power 5. So here correction, plus sign, 1 upon 5 r raised to power 5 minus here 2 by 3 r square and here r cube, which will become r raised to power 5 and square bracket close. Now here you can see there are a common term r raised to power 5 which we can take outside the bracket. So therefore I is equals to 3m upon 4r cube. I have taken r raised to power 5 outside the bracket. So I can write the remaining terms 1 plus 1 by 5 minus 2 by 3. So here we need to simplify this term. So see what I am doing. Therefore I is equals to 3m upon 4. Here I can cancel out this term. This whole term gets cancelled out, and here the remaining will be r raised to power square. So here the only term remaining will be 4. Let me change the ink. The only term remaining will be 4, and here the only term remaining is r square. So now here I can write 1 as it is, and I am going to do the cross multiplication between the next two terms, that is 1 by 5 minus 2 by 3. So if here I am doing the cross multiplication, what we are getting is 1 into 3 is 3 minus 5 into 2 is 10 upon 3 5s are 15, bracket close, and this square bracket. So therefore I is equals to 3 by 4 m r square 1 plus what I have remaining with minus 7 upon 15, which is nothing but 1 minus 7 by 15. So therefore I is equals to 3 by 4 m r square 1 minus 7 by 15. Again we are going to do the cross multiplication here. So in denominator of 1 there is no term, so here we can assume 1 in the denominator. So therefore I is equals to 3 by 4 capital M capital R square. Here after doing the cross multiplication, 15 minus 7 upon 15. Therefore I is equals to 3 by 4 m r square. So we are remaining with 8 by 15. So now here we can do some cancellation. This one time, this got 5 times, this got 1 time, this got 2 times. So we are writing the remaining term I is equals to 2 by 5 m r square, which was our required equation. So here we have find the moment of inertia of solid sphere. Capital I is equals to 2 by 5 m r square, where capital M is the mass of solid sphere, capital R is the radius of solid sphere. So here we have derived the equation for moment of inertia of sphere about the diameter x dash. So thank you for watching. Please subscribe for more videos. Bye.